3.0, it's all about natural language programming, right? So English programs are written in English, which AKA we can call it prompting, but these LLMs become programmable computers. Hello, and welcome to Generation AI, the podcast where we demystify artificial intelligence in the world of higher education. I'm your host, Ardis Kadiu, and with me today is my friend and co-host, Mr. JC, or Dr. JC Bonilla. Hey, JC.
Ardis, what's going on here? We announced last week your transition and your evolution. You're ready to changing the script here. I noticed you want to introduce certain things, higher education and other things. Is that what's happening here? We're ready, evolving with your evolution.
Hey, it's called Generation AI, not Generation Higher Ed. No, I'm just kidding. But yeah, last week was an interesting episode. It was a good episode, and I thought that we needed to do a geeky episode this week. So
we got a little soft. It was very human. I even cried a little bit. So nerd power. This is a strong technical dive, and we were both taken away by a keynote. And today's conversation is about software 3.0. I'm so excited, Ardis, and I think you're going to be driving this today, more your forte, and I'll try to catch up with all this evolution of the software sector as we know it. So should we provide context?
Yeah, no, absolutely. So Andre Karpathy, for those of you who don't know him, he's worked at Tesla. He's one of the founders of OpenAI. Really, really innovative person. He's worked on the Tesla self-driving cars, and he gave a keynote at the Y Combinator, and it was called "Software is Evolving Again," right? And we thought it was some of the ideas there were amazing. And what we wanted to do today is discuss what that means, go through that keynote and some of the ideas there, try to put them into the context of how we think about it, the industry, even higher education, and how kind of how we see that next evolution of software. And perhaps the most important thing here is, as part of Generation AI, it kind of fits really nicely with how we've been thinking on AI and how computers and AI basically democratizes programming and creates a new class of partially autonomous applications and so on and so forth. But so, anyways, well, we can get started.
One framework or mental framework that I recommend everybody to program yourself as you listen to this episode. Number one, it's software technically intense, and we'll be trying to understand why are JC and Ardis having this conversation about software. And it's just that the current deployment of AI as we know it and how it stretches the boundaries of AI development or the emergence of the AI engineer, it's literally what's creating this foundational shift, right? And this foundational revolution kind of tells us how computers, what they do, how they think, and specifically, because we're Generation AI, what does it mean today and where is this going? So I think you're going to take us through these software stages, like what is 1.0, 2.0, so we can really unpack the 3.0 version that AI is creating. So, Ardis, you want to talk about this 1.0, there's two eras leading into the third era framework?
Yeah, no, absolutely, JC. So we're really living through kind of this third foundational revolution in how we tell computers what to do, right? And this time we're really programming them in the same language that you're listening right now, English. So if we go back, the three eras, if you think about these three era frameworks, you have software 1.0, which, starts from 1950s to 2010s. It's explicit instructions written in programming languages. You talk about Python, C++, COBOL back in the day. But humans write every line of code. Mainframes.
Good old mainframes. Yeah.
You think about it, it's deterministic, it's predictable behavior, you write tests around it, and you write a function to classify an email as spam, right? You You basically say, hey, this is the keywords that I need, or this is a spam, this is not spam.
We can say you and I were classically trained as engineers on
Correct.
this era, right? The traditional programming mindset, right?
Exactly. So if you're writing code today, like that's probably that software 1.0, and a lot of SaaS businesses are built on that. Now, moving on to software 2.0, and kind of Karpathy references this back in 2017. He wrote an essay about this, back then. But essentially, programs written as neural network weights. So that what that means is that the first time humans write every line of code. During software 2.0, you provide data and you build models, and those models is how, like, the software 2.0. So you think about perceptive AI, you think about these neural networks to classify that email as spam. You just give them a whole bunch of examples of spam emails, non-spam emails, and then the software is that neural network that actually builds. So it's the weights and everything in that neural network that essentially that's the software part of it. So we moved from software 1.0, which we write all lines of code, very deterministic, to software 2.0, which are written as neural network weights. The data and architecture define the behavior, and training, think about the training, compiles the program, right? When you train, you're basically compiling the program, and the humans become data curators rather than code writers. And an example of this is training a neural network on billions of these emails to learn how to spam detect, right?
100%.
Now, and that's from 2010s to 2020s, right? So it's about a decade. So if you see the first one really, really long, about 60 years or so, the second one pretty short, about 10 years, and we'll talk about the third one, which software 3.0, which is just literally just 5 years now, or maybe just a couple of years.
This time compression that you just alluded to, it's a very natural process that we see in technology. So think about what you saw from there's these famous charts of the evolution of radio, then TV, and then the internet in terms of adoption and the cycles. So we're obviously we're seeing that as it relates to the programming language. I just wanted to double click a bit on the neural networks, because when people think about, and when I first heard of this, traditional programming, C++ and things like that, but what do you mean with neural networks? How is that a programming language, right? And it's not that it's a programming language per se, right? It's this approach of using a neural network. So what it means that it's brain inspired, and as such, it's about the tuning aspect. And so software engineers kind of go through those motions that are not what you saw on that first wave, deterministic, or the data object, and the things that we see in Python, C++ is kind of what rules. So these introductions of other methodologies, in a way, shape the software industry, which then takes us to this version, this framework 3, or software 3.0, right?
Right, exactly. And 3.0, it's all about natural language programming, right? So English, programs are written in English, which AKA we can call it prompting, but these LLMs become programmable computers. So the large language models that we've seen now over the last few years, and we've been working with, they become the programmable computers, and everyone becomes a programmer. And think about now, in this case, is you just give it the LLM a prompt. You give it an email and you say, classify this email as spam or not spam, and done. So you've kind of transitioned from, you write a function that looks a lot of things around that email, to now using a neural network to classify it, which is the traditional ML approach, right? Machine learning approach with data, driving that, and now natural language with these LLMs becoming programmable computers. So this idea of the large language model, or AI, we can call it whatever we want, but that as a computer, keep that in your mind, right? Because each of these transitions represent a foundational abstraction layer. So we moved, like I said, from machine instruction to human readable code, to data driven models, to now natural language instructions. Make sense?
Yeah, and let me just paint a picture for everyone who maybe doesn't come from programming languages, but you may seen code in the traditional software 101 code. Look like that classical script that has functions, definitions, and kind of data structures that are very like code, right? On version 2, if you had an actual a look at the code, it starts introducing a lot of arrays because you need to start bringing these weights. What happens in 3, to your point, right? You start seeing code, but also like big statements in English, like the way we would talk and the way we would write. And that's a big, big departure in that evolution that we're talking about. And programming in English, it's a fascinating thing, that natural language processing. So let's start peeling this 3.0 version. And this is where it's going to become a super fun technical conversation. Go for it, Ardis.
Yeah, I mean, so think about the large language models or these LLMs as the new operating system, and also if you think about that model, there's an understanding there's an infrastructure shift that is happening, and Karpathy, what he observes is that these LLMs, they have properties of kind of utilities, fabs, and operating systems simultaneously. So I don't know if you follow Andrew Yang, but basically, earlier on, in a couple of years ago, he said that these large language models, or the LLMs, are essentially, or AI is going to be like electricity, right? So it turns into a utility. So it kind of powers everything. So AI powers everything that we do, just like electricity and utility. So we've seen that happening right now, where everything is being driven by AI. Now you can buy tokens essentially from all the service providers, and it's any of these models, what they produce is tokens. You buy those tokens, they're getting commoditized, and now you can switch from one provider to another provider to another provider, depending on kind of what type of workloads you have. But there is really not a lot of differentiation, on those token productions, right? And it becomes a utility. So as utilities, there's this massive capex investment. So it's like building a power grid. So you're going to have, not everybody can build power grids. So you're going to have like these very few companies that are going to have that. The metered access, you pay per token. It's very high uptime and reliable. The expectation is really high. And when they go down, essentially, the whole world stops, because nobody, last week or 2 weeks ago, ChatGPT went down for a little bit and everybody's freaking out. It's like, what happened?
Yep. So to rebuild the analogy, I just turn on the lights. I have electricity, right? This is me prompting right now, how do I cook this, I don't know, rice pudding when I have this ingredient, and ChatGPT gives me that, right? What is happening behind the scenes is that the instrumentation, the infrastructure, that the utilities, right, is that frontier lab that has put tons of resources building their infrastructure, and or collaborated with other partners to get the cloud computing, the training, the data, the fabs, right? And that ecosystem kind of supports us.
So as you move from utilities, right, and the other thing that you can think about this is kind of fabrication plants. So not only, so utilities are very simple, but with these LLMs, there's just enormous capital requirements for training these models. There is deep technical, and R&D secrets. There is different process nodes, meaning like there's model sizes, capabilities, and so on and so forth. So you think about this as kind of a fabrication plant, right? That's so this LLMs and this infrastructure becomes an LLM. But the third part, which is perhaps the most interesting part, and what we're going to focus on a little bit more today and start thinking about that way, or at least that how I connect to it most, is the operating system, right? And the large language model as an operating system. It's essentially redoing an entire computing platform. It's a new computing platform where we talked about this before. As we talk about agents, it's like the LLM is really the CPU. The context window is that RAM or the memory, meaning like how much stuff can you put in there, and then apps that run on different, as essentially LLM OSs, right? You have ChatGPT, or you have Claude, you have Gemini. So all of these different kind of OSs. You have the closed source ones, which we talked about, and then you have the open source ones. So right now, what Karpathy said is like, hey, we're in the 1960 era of
That's
computers, right?
unbelievable.
Where
That's
it's just
unbelievable.
like, right? Because everything is so centralized. We can't run these things locally. So think about 1960s mainframes. So the computing was so expensive, it's centralized time sharing model. And now we're all kind of logging in with our thin, whatever it is, with our terminals. And personal LLM computing has not arrived yet. So this is interesting when you think about it that way. Like the Mac, like your Mac or your iPhone, personal computing, or your terminal, or whatever that you had at home. I don't know which one is your first computer, but it hasn't arrived yet, right? Because we're still logging in to get that intelligence from these big providers because it's so expensive to run them. So we're essentially redoing the entire computing revolution, but the intelligence is the primary abstraction rather than just the computing part, right? And what's kind of missing, it's the GUI part. So remember Apple revolutionized the GUI.
GUI as in graphical user interface,
It's their
right?
interface, right?
Yeah,
And
of course. The double click, the click and drag,
exactly,
these experience that we deal with today, that revolutionize personal computing, emerges from just basically a shift of going from prompt terminal. Right. You asked me about my first computer. I'm an IBM 186 to 86, so I went through that process. So yeah, you went into command land, your prompt, and you use DOS to basically give instructions. Feels like today, by the way, and execute the code that maybe sometimes it was not even on hard drive because you needed to actually insert the disk, and that is 1980s type of technology. So to be 60s, this is where there were these cards and the punch cards, right? That's the type of analogy that they bring today. But back to GUI, what you just said, which I think is fascinating, is there's these systems that would look like an evolution, but the GUI right now is probably one of the biggest things that do not exist and we don't see it coming, or is Karpathy saying it's ahead, but this is probably one of the missing components.
yeah, yeah. And so look, basically his compute his if we're LLMs are the new computing paradigm and we're looking at intelligence as a new computing paradigm, we're still in the terminal phase of that computing paradigm, right? So it's like it feels that there's no GUIs for this new computing paradigm. Maybe voice becomes that later, maybe not, but essentially right now we're exactly what you're talking about. We're just command line terminal. So the graphical user interface for intelligence hasn't been invented yet, and we're in the really early days of that part of it. So it was really interesting that he kind of described it that way because it's very, for a lot of us, we think like, oh, like this, there's just so much intelligence and all these things are happening. But if you look at it in the history of computing, if we look at this as a new computing platform, we're very, very, very early on.
This just one take on the GUI and the user interface. Do you think we'll skip that phase altogether and we just go to voice? I just struggle to see how we interact with click and drops the way computing was needed. So graphical user interface, a la Mac. And I think we're just going to go into voice, and it will be a totally different graphical user interface, more like a human user interface, right?
So look, the reasons why GUIs are so important is because our computers, our meat computers, are so good at interpreting high bandwidth information via visually, because that's our, like right now LLMs or AIs are so bad at the physical world because they just can't process that much. Whereas our computers in our head, like our brains, visually, like our visual processing is like so far ahead than anything else out there. So visually we can take a lot more information in. So as we interact with these different systems, yes, voice is important, but in terms of bandwidth and how we communicate, like visually, we can absorb a lot more. So if we have things that we can click, things that are, representative of kind of the physical world type of situation where there you have location and you have depth and you have, you know what I mean, like shapes and sizes. Like there's just so much information that can be encoded in that that that's why GUIs are so important. So no, the answer is I think we're not going to go to voice, because voice, like, there's a sense of discoverability also that is not there with voice. So we're going to have a hybrid, but we'll have to see how that evolves, right? So I feel that we're always going to be having this ambient multimodal type approach and how we interact with it. It's just that those text right now, it just feels very, very, very slow.
Interesting. Same type of question, but now in a different domain. And you've been very close to trying to understand superintelligence and AGI. So where is Karpathy thinking, bringing the whole superintelligence? Because this is going to be built for a LLM or an AI that achieves things that humans, we are not interested in doing, we're not good at doing it. Just that emergence of superintelligence is interesting. So how all these things put together?
Yeah. So basically, it's interesting. Like, he's calling this LLMs or this AIs is calling them people spirits, right? Like, he has a framework that's calling them people spirits.
And for the audience, he's the person who coined vibe coding. So he's fantastic at basically labeling these things and give them stickiness in terms of what they should be calling, coining these things. So sorry, go for it. Digital spirits. You got me at spirits.
Yeah, it calls them like this people spirits, right? So he calls them LLMs are stochastic simulations of people.
Oof, that means random. Stochastic means random. Why am I feel like I'm translating you today. Everything you say, I'm just saying.
Great. I mean, yeah.
Okay, go for it. Keep.
This is good. So stochastic, it just means, yes, random, but there's noise. You don't always get the same thing. So it's like, it's probabilistic, right? So yeah. So, but they have superpowers, right? They remember everything, right? They can process a large amount of information instantly. It's like having Rain Man with access to a whole human knowledge, right? It's like, have you seen that movie, Rain Man?
Of course, right? Yeah, just recollects everything, reads the phone book, and basically remembers every number and can bring it into context. That's the point. That has the memory and knows how to extract it and put it into a play, or when they're going to the casino, all that kind of good stuff.
Yeah. And but there's also there's hallucinations, and we know about that. Like, they have what they call jagged intelligence here, right? So superhuman at some tasks, and when we talk about narrow intelligence, like very, very good at certain things, but really bad at other things. Like, think about how you tell an LLM, what's greater, 9.11 or 9.9, and the answer is 9.11. They come back with, it's like, well, no, a human person actually understands that 9.9 is bigger than, but those are the kind of things, right? There's no long-term memory for these LLMs or learning. So the context windows is just the working window, right? And if you think about, like, I use the analogy of 50 First Dates. I don't know if you've seen that movie as well. It's like a lot of movie analogies, but everything gets wiped clean. So they don't remember anything, right? So they don't remember anything, these LLMs, and you need to have context in there. And again, like, there's other things that are kind of, there's some deficits there as well. But unlike human co-workers who learn and kind of the organization over time, the LLMs really suffer from that digital amnesia, right? They wake up fresh every conversation. They fundamentally changes how we design systems around them, right? Because if there's no memory, then how do you design systems around this? That they can't learn new things, right? And how do you make an operating system that does that? So we need to build applications that account for both the superhuman capabilities and the very human-like limitations of these systems, which is perhaps really, really hard to work with, as a lot of classically trained developers, they have a really hard time getting into working with LLMs and AI because of the unpredictable, like, they're going to get different results different times. And it's like, well, how do you build a whole system that can still get you the result, but, without coding everything, line by line? So that's an interesting process on how you do that. What Karpathy is actually, essentially articulating here is that yes, we have this intelligence now. It is like electricity, or it's like a new way of thinking as an operating system. But in order to build on this new operating system, we have to take into account the power and the limitations, right? The memory and the context, and kind of the things that fall apart. And there is going to be what he calls a kind of a sliding scale of how we build systems in this new model. And he essentially says that when we're building software 3.0 or software 3.0 applications, there's key features, right? And there's 4 key features in software 3.0. So one is, how do you manage context? So remember that memory. It's like you need to understand how to manage that memory. So LLMs, they handle complexity, but you don't want to manage a lot of that. So it's like, how do you do that? That's really important. Multi LLM orchestration. It's like, how do you manage the different, models for different tasks under the hood? Will that evolve to a place where we're going to be able to use one model? I don't think so. How do you think about application specific GUIs? You know what I mean? Like, that's this idea where you need to have visual differences, and so on and so forth. And then the fourth one is the autonomy slider, right? So it's like this tab, essentially, like, how much autonomy do you want to give the AI versus how much do you want to control it? And all of this is kind of the cursor model. Like, I don't know if you're familiar, but we've talked about this. Like, cursor is the coding agent, and the coding IDE, and essentially he highlights cursor, and he provides all these different key features of cursor, right? It handles context management, it handles orchestration, it handles some of the specific GUIs, and the autonomy slider, you can have tab completions, you can have file editing, but then, on the all the way on the other side, you can have cursor basically write a full repository of changes, which is pretty interesting.
And the part that is interesting for me, it's with this autonomy slider, right? So you give either partial or full autonomy to an LLM, and this idea of the context, the multi-orchestration, and probably the visual components of the GUI, it's literally what you are saying. Go all at it or stay within your boundaries. So I think that's an interesting way to bring it all together. But yeah.
Yeah. So this is all about agents, right? So he talks about agents as like, hey, we have this new operating system and how we think about this, but then the building blocks are now we move to AI agents, and he says agents are really overrated, right? This is going to be not the year of agents, it's going to be the decade of agents, because agents are going to evolve over this decade and how useful they're going to be. And you have this slider of autonomy in those agents, right? The slider is starts from very little to very high. And I think the best analogy that he uses, and maybe this is something that, if you remember very early on in some of my presentations, I use this one as well. It's the Iron Man suit. So the Iron Man suit is augmentation, and essentially it's there to augment Tony's and to make him superhuman, and provide all of the capabilities for him to fly and to do all the things that he does. But on the other side, it can also be autonomous as well. So the AI in there, Jarvis, can be autonomous and can work alongside Tony. But there is a sliding scale. So this idea of human in the loop, and kind of this idea of like, how do we have, like, where are we in that scale, becomes really, really interesting. So we want tools that make humans superhuman, not tools that replace humans necessarily, right? And that's kind of, he calls that out, and that's why he talks about agents are overrated, because everybody's talking like how agents are going to replace humans right away, and we're going to get this amazing autonomy, but we're not just there yet. And there's going to be a lot of building to do over the next few years and decades. And that's kind of what excites me as well, because I look at that and I'm like, holy shit, yeah, it seems like everything is moving so fast, but there's just so much systems and software and all these things that have to be rebuilt, that it's going to take us quite a bit of time to get there, and then we're just getting started. He also talked about the Tesla, because that's what he worked on. Like he gave a really good example of the Tesla autopilot, where he spent 5 years like building the self-driving capabilities of Tesla, and he's like, look, we like back in 2015 or 10 years ago, he got in a car in Waymo and it worked, and he's like, holy shit, we're here, self-driving is here. But a decade later, we're still not there. So we're almost there, but we're still not there with self-driving cars. So we overestimate how fast this transition is going. Does that make sense, JC?
Of course, and maybe a way to see it is with one of his quotes: "2025 is the year of the agents, dangerous thinking. This is the decade of agents, more realistic." So, what he, as probably one of the leading innovators, but also operators of AI behind the scenes, and in terms of use cases, this is a refreshing perspective of the progress that we have built. It's incredible, but we're still not there for going all out. So I do know that 2025 is the year of agents, but in terms of partial autonomy, full autonomy is where I think his statement, that decade of agents, is more realistic. What's your sense on that?
Look, I tend to agree, but it depends on what types of applications. So agents are going to, affect, and they're going to be autonomous in different parts of our workflows. So yes, the full self-driving car, that's an agent that's working in there, but sending communications out to students, that's going to be autonomous. I don't think we really need partial autonomy there, because who's going to look at thousands of emails that are going to go out? You can trust the AI, provide him some guidance, and then slowly kind of drive that. You know what I mean? So that interaction there with AI, so different systems are going to have different levels of autonomy, but it becomes really interesting. Look, like I said, software 3.0 application is going to have that slider, and we talked about how developers have to get used to kind of programming in this new paradigm, and what the quirks are, and what how to guide this people's spirits, so to speak. And then the other part that's really exciting for me is that what this software 3.0, the most, I would say, unprecedented aspect of the software 3.0, it uses natural language. So anyone can communicate and can program them now, right? So the prior to waves of software, it required technical expertise. You had to be trained on it, and so on and so forth. But now the programming language is English. And you mentioned Karpathy was the first one to say and to coin the word vibe coding, but in reality, it's much more than just the process. It's just like how you think about programming now. It's very different, and the access and democratization revolution it's here. Personalizing student engagements is only possible when enrollment management and marketing communications are aligned. At ABAC, Ryan Hogan's team used Element 451 to improve student outcomes.
So not only do we design emails and things, but we can also have landing pages that can give information to our students. And so it really brings the team together. So our enrollment staff is helping identify what the issue is, and then the marketing communication staff can collaborate with them in Element to provide the solution for the problem we're trying to solve.
Aligned teams create better experiences for students. Visit element451.com to learn how an AI-first student engagement platform fuels a smarter, more connected campus experience.
The 5-year learning curve, like you and I spoke early on, that we were classically trained on this traditional software 1.0. It took years to be competent, and more importantly, to be DevOps ready. It's just the whole code base. It's just there was a lot of blockers. So I think that a programming paradigm shift that uses communication as a new program, in this case English, very interesting. And this is where you see kids doing it. Have you seen kids vibe coding, by the way? Are your kids doing this?
No, but actually, I've seen videos of this this classroom, and he showed it in his demo, or in his presentation. He showed this video of kids vibe coding and building stuff, and it was like a classroom of, I don't know, like these were like 70, 8 year olds or 7-year-olds.
Yep.
It's crazy.
It's very interesting. I've been talking to my kids 7 and 4 about phones and computers and AI, and it's a very interesting construct. So taking them to the aspect of democratizing coding at that earliest age is fascinating. So that's definitely going to be a fun way to go about it.
So I just a quick story. We last week at Engage, I had a presentation on vibe coding, and I think I've gotten the most nice feedback about that presentation, and people calling it out. We weren't even going to do it. Like Petter is like, well, it's like, nah, I'm not going to do vibe coding, and like I'm a serious developer here. Like, screw this vibe coding thing. So I'm like, all right, I'll do it. And I've been using a lot of a lot of these systems, and we used Lovable as part of that presentation. And I got the nicest note from someone, a CIO yesterday. Is said that, hey, I just want to tell you, like, I love Lovable.
No pun intended.
And is like, he had 2 hours in the morning, and he whipped a prototype together that the provost kind of asked them to do, kind of a web accessible, searchable database with copies of syllabus in for every class in the past. And is like, I whipped it up, a prototype in 2 hours, and already got sign off, and we just don't have the resources in here, or don't have any of those coders. I would have had to scope this project out. I would have had to, find resources, and then months later hire a consultant to do it. But, building that prototype was really interesting. So it was a really, really nice note that I thought, I would share, because this software 3.0 now gives access to a lot of people, being able to access it. Even though it's not there, it's not perfect. Yes, you need to have security, and yes, you need to have all those different things, but trajectorily is going in the right direction, and it becomes a lot more accessible.
For me, the punchline here, as I hear you recap the keynote, which I also had the opportunity to listen to, right? This paradigm shift, software 3.0, it's really where AI takes a prime seed, and then we're starting to see how it reacts to, right? And these are basically the low-hanging fruit and the changes. In traditional infrastructures, where we're departing from, right? Payments, authentication, they were designed for human clicking, right? So It's a really interesting shift, and this is where evolution and vibe coding and things that we just discussed kind of start grabbing from, right? What else do you want to talk about? We're kind of minute 40, and there's so many things we can come and expand here. So where do you want to go from here, Ardis?
Yeah. So then, essentially the next thing, the infrastructure opportunity for building for these agents, and building for this new paradigm of software 3.0, we now have 3 types of digital information consumers, right? Like we have we have humans who use GUIs, we have programs or applications who use APIs, and then we have AI agents that we're building. And it's like, well, what do they use to communicate with people? And one of the things that have become really, really popular is, just like you have a robots.txt for your website to kind of scrape, now you can probably have an LLM.txt file, right? That just describes, so you don't need the click here. And so like LLMs are not very good at that. It's like click where, it's like there is no link in there. So essentially they understand text. So we need to build infrastructure that is built for these agents, right? And essentially, even as LLMs get better at clicking and navigating, it's really worth optimizing these interfaces for AI consumption. And we're going to see that quite a bit happening. We're already seeing the transformation in consumer behavior and how consumers are accessing your content and your website through just this LLMs, right? You saw how Google overviews now is scraping your website and not sending people to your website, but it's actually producing the information in there. AI mode. We'll talk a little bit more like how the whole content world is is facing this huge paradigm shift where, like how do you produce content and drive people to your properties? So anyway, so that's the part where we're super, super aligned. And we talked about MCP as a protocol for these agents to kind of interact together and to kind of pull information from different systems. So that's happening right now. And that's the part that software 3.0 is going to need a lot more of those things. Now, let's move into like what are some of these implications, right? Like what does that mean? Like for education, entrepreneurship, and maybe even the kind of traditional SaaS as well.
Yeah, let's do it. And can we start with education here, given our audience?
Yeah. So we've talked about this before, but current education assumes scarcity of information and tools.
Of course.
Software 3.0 creates an abundance of both of those.
That's example that we saw through our partners at Gordon State, right? So I don't have the application developer. 2 hours later, the prototype is done, approved, and ready to go. So access and proliferation of POVs and work, right?
Yeah, exactly. Karpathy is also in education. He's actually building education systems, which is
that's
really
his company now, right?
Yeah, exactly. So he can kind of. So he gave an example where saying like the educational framework where he's approaching it is keeping the student separate from the teacher, but they're working off of the same artifact, which is this auditable, consistent curriculum. Is like, how do you keep AI on the leash, so to speak, with structured learning paths? But then there's a human AI collaboration loop in the learning as well with the student side. So very, very interesting. Go take a look at the video, because there's a couple of minutes in there where it makes a lot of sense on how you're building learning systems and building this software 3.0 for learning systems, and maybe it's LMSs or whatever, but that's an interesting space in there.
The part that I like to probe here, in the way I see it, right, in a way also goes back to our episode on AGI, right? These new frameworks of educational teaching, and what this teaches us, right, is that letting AI do the knowledge diffusion, it's very smart. Letting humans probably take on the coaching and the empathy build up, right? The being humans, it's probably better, right? And this is where that collaboration, coexistence of co-intelligence in learning, it's where is that.
So the other part is like, hey, like the skills shift. So before, as you're programming for software 1.0, you had to learn the syntax. Now it's all about you learning prompt engineering or context engineering. We'll talk about context engineering in a future episode. It goes from memorizing these algorithms and how to implement them, in terms of like, now it's understanding when to apply them and how to kind of connect these systems together. And then it's like moves from how do you do evaluations, which we talked about before, well, actually moves from debugging code, right, to like, how do you actually build evaluation systems and how do you debug AI reasoning, which is really, really interesting. So again, the opportunity there is interesting.
Yeah, I was using this analogy the other day with a family member of like AI reasoning, right? And I landed on an example that I hope it helps everybody here. It's very similar to how lawyers are trained. A lawyer, to defend argument, is trained in logic, right? Because that human reasoning in logic is what allows you to come and say crazy things or defendable things. Probably our software developers and engineers, as they go, are trained up. AI reasoning would look like AI logic, right? And this is how a decision gets made, and the layers and these kind of decision paths that it uses, and how that takes place. So scaling that knowledge is probably where it's at.
Yeah, exactly. And so if we think about the entrepreneurial opportunity here, it's moving to this 3.0 migration. Like every application can become partially autonomous. A lot of code or a lot of the systems have to be rebuilt for this new OS, right? New class of applications that were basically impossible before without natural language programming become possible. And the ecosystem, the tooling ecosystem, completely needs a rebuild for the 3.0 stack. So huge migration opportunities, both on the software side, also on the systems side as well, and how organizations are essentially delivering value through this new way of, I guess, through this new infrastructure, so to speak, intelligence infrastructure.
And just, I remember the transition of, their early 2010s, 2015s, right? It's when the big data emerges that pipelining and these infrastructure companies and capabilities were just such a incredible industries. $1 billion companies emerge from just basically looking at behind the scenes, aka the plumbing, right? We're talking about the same thing in terms of entrepreneurship. Billions of dollars will emerge so that you can move your stack from where it is today to this 3.0 stack that is basically AI native and AI ready. So it's an incredible opportunity. Artists, don't build that company, okay? Don't.
Hey man, like this, I told you we're going to be building in the open, or we're going to be talking about this stuff in the open. So there's we're going to be bringing a lot of these thoughts together here.
There you go.
But there's also infrastructure plays as well, right? Think about, like, what does an AI first authentication or payments look like? It's that's something that we don't see yet. Like, what does this visual debugging tools look like for LLM applications? Is crazy. Like, data set management and version controlling in the world of in the world of these LLMs. And the most important and the most exciting things for me is, like, how do you coordinate agents and orchestration platforms? And that's what Element is building, which is pretty exciting, right? Like, how do you build those pieces? And every application is going to need to go through that as they agentify themselves and the workflows get agentified. Building the orchestration is really, really important.
I also like that one a lot, and it's one. I've been giving this example a ton. When you think of agentic, right, is I'm going to have an agent to do my emails. Like, no, you're thinking the wrong way. What you want is to have 100 agents do 100 variations. They have another agent pick the best performing piece of content. That is the mind change that we're upon. And what you just talk about is that orchestration and coordination. It's all powered by also AI and the infrastructure to be built. It's a fascinating play.
Yeah. I mean, if we want to use another movie reference, another Marvel reference, have you seen when the Avengers were Doctor Strange analogy, where he goes in and he looks at millions of futures, right? And then there's only one where they win. And you're going to do, like, it's the same thing here. Like, you're going to have the capability of this hundreds or whatever, however many agents go build in parallel all these different versions, and then you're going to take the best one, like you said, which is pretty interesting.
Yeah. We designed, just using the content analogy, like, I design content that gives me on average the best open rates, right? That's a metric, and that's how best personalization takes place today, right? In the eyes of of AI, I could design a trillion versions, right? That just causes you to go to this link. I'm not even interested in you open it. Just, I want you to go and drop in this specific link, and that there's the one that got you there. So I'm going to come in and personalize that one out of permutations of all the tokens, content, visual components that you can have. There's that one. So it's incredible. Anyway, all right. What about traditional SaaS? You said that this is also applying to your building. So companies like Element or anyone in EdTech, if anything, right?
Yeah. So there's going to be a transition for a lot of those. It's like, and look, there's more questions in there that there is there is answers right now. So, like, you think about this autonomy retrofit, right? Like how do you retrofit things to be more autonomous, right? The traditional SaaS, it's very, so it's like, how can these LLMs basically see everything a human user can see? Like, you're building the computer interaction models and the LLMs and those agents, but maybe that's not really the best way to go. I don't know. Like, is there a different way? Can LLMs take all the actions a human can take? Like, how do you build your system? How do you retrofit them so the LLMs can take all? So there's no more click here or basically it's like, just enter this piece of information. Like, that's going to be, and there's going to be a transition there. There's going to be a gap of traditional SaaS, moving in that direction. And then how do humans supervise and stay in control? Like, that's still a question mark when in the new operating system or in this new software 3.0, like where does the human come in and how do they supervise and stay in control? We just, those are all opportunities, right? It's like those are opportunities for the retrofitting part. And also the interface revolution needs to happen as well. Like we talked about and said, current UI are designed for human clicking. So we need to design UIs for agents. We need AI accessible equivalents for every action, right? It's like, how do we do that? So everything that we do right now, every software, every piece of interaction, everything needs to have an equivalent. Yes, we're starting to think about MCP as an interface, but even MCP is showing a lot of cracks where like this agents are not, or this models, like you stuff 50 tools in there and they just go crazy. It's like, imagine having the ability to have, 100 or 200 different tools. Like, how do they choose between them? It's contextual. So like we have to build that as part of that. And then again, traditional software, like it needs to transition to agent ready, right? Even becoming agentic itself, or being agent ready so it can be used by agents, or it's going to get disrupted. There's going to be an AI first or an agent first piece of software that's going to come on board and replace them if they don't transition. So huge disruptions that are coming not just on the business model, but also like just from a technology perspective of the traditional SaaS.
So Ardis, let's start recapping and see if we can move into our actions for our audience. This is gigantic. The big picture is very interesting. We are redoing computing. And this unprecedented technology diffusion, it's upon us, right? And it's basically building a new infrastructure, front end, back end, front end, at every component that it will make us AI ready. In this conversation, you communicated to us that Karpathy puts us in the 1960s. That's kind of where we are as it relates to computing. That doesn't mean that we are 40 years, or actually 50 years behind. It's that it could happen in very, very short times. And we're all talking about these network effects of intelligence, right? And how it's going to come. All right, I got it. What do I do now? I mean, if I'm a developer, if I'm an entrepreneur, or anybody in our ecosystem, how do I start basically adopting this paradigm shift? And if I'm 1.0 or 2.0 or 2.5, how do I become 3.0 enabled? What do you think?
All right, so we'll start with developers. You have to learn the
talk to Peter. Talk to Peter that he's a serious developer, not a vibe coder.
Peter is right. You have to learn all three paradigms right now. You have to learn 1.0, you have to learn 2.0 and 3.0. They need to coexist, at least for the near future. And then you need to understand when to implement what. So as a developer, you have to learn the three paradigms. You can't just learn one or two or three, and then you have to be good at all three. You have to start building kind of what's called partial autonomy into existing applications. So we talked about like what the opportunity is, the migration. You have to start building that autonomy into existing applications. You have to focus on kind of the generation verification loop, meaning that you got to make humans oversight fast and easy. Mm-hmm. So the idea that as you move to partial autonomy, you have to understand how humans are going to, like, you need humans in the loop, but you got to make that really easy. Like very, very fast for that oversight and really easy. You can't have agents spit out for you this really long list, or have a queue of thousands of emails that you have to review, and now you have to go click one by one to approve all of them. You have to make it easy. You have to basically make it so that the humans can say, oh, I approve one email, and then the rest of them follow those guidelines. Or, that's just a really simple example. But if agents are going to become important, and then experiment with agent first interfaces for the product side, right? So it's like, how do you build interfaces that are agent first? So those are the things around developers. Now, when you move to entrepreneurs, it's interesting opportunity, because you have to the first thing is like identify 1.0 to 3.0 migration opportunities in the industry. So this is probably the biggest one. It's like focus on, like, if you know best what industry or what vertical or whatever, like, what's the opportunity to move from 1.0 to 3.0 software, from software that's built in SaaS right now to software that is agent first and that is using this this AI first approach. Build infrastructure for the stack, so huge greenfield opportunities on infrastructure. Infrastructure is very, very early on. Yes, there is the OpenAI APIs, and yes, there's a lot of that, but there's so much more infrastructure that needs to be built for the 3.0 stack. That design with the autonomy slider in mind, so let users control the AI involvement. Like, as an entrepreneur, like, you can't just, like, yes, things are going to move there, but if you want to have adoption, and adoption equals success, and there's a loop there, right? So adoption gives you data, gives you feedback for those agents. So the adoption becomes important. So provide a control for the AI involvement in the systems that we do in order to accelerate the learning and in order to accelerate things. And then the most important part is, like, remember the Iron Man suit principle, right? So augment humans. Don't replace them, or even have a slider there, so they decide, like, how much of their involvements you want in that suit, right? So if you want full autonomy, then just let the humans control that. Moving on to, for all of us, right? If you're not a developer or entrepreneur, hey, look, I'm not gonna say it, but just start vibe coding, please. Everybody's now a programmer, so you can. Whatever, you can build anything.
Learn to love lovable. Learn to love lovable. Or whatever application. Yeah.
Or Cursor or Bolt or Replit or, any of those. Yeah. This the most important thing that kind of stuck with me as someone who's, like, building fast. I'm like, holy shit, the opportunity is moving away. So understand that this is a decade-long transition. And it's not just a hype cycle, right? This is not just a hype cycle. It's the transition is happening. It's going to be, a few years to a decade. I don't know. Maybe it'll be a little bit shorter than that. But this is not a hype. Focus on human AI collaboration skills and kind of the future of work. So how do you think about human AI skills? How do you learn how to prompt better, to do context engineering, to work with these AIs, and that becomes part of your kind of identity. And essentially, if you remember from last episode, we talk about the talent wars and how important these AI first, workers that are building AI are, like, that's going to be super important for the future of work, right? We're going to need more and more and more of that. And I don't know. I mean, this is kind of that 3.0 moment, right? So it's just thinking through that and what the opportunity is becomes really, really exciting. But just start. I guess that's the action here. What do you think?
I'll read a quote from Karpathy's closing message to summarize. What do I think? What an amazing time to get into this industry. We need to rewrite a ton of code. But going back to the Iron Man suit analogy, I think what we'll see over the next decade is we're going to take the slider from the left to the right, end quote. Unbelievable, right? It's just that the quest for autonomy, call it a 3.0 movement, AI first, whatever word kind of sticks to you as we had this conversation, we are in the midst of it. So what do I think? Excited to be here, excited to be in the journey. I've been told about the internet revolution. I've been told about the digital revolution. This is the first time as a leader I'm in a revolution. So I'm riding this wave and I'm all in, Ardis. That's what I think.
Yes. All right. Love it. All right, everybody. Hopefully this was useful. I know this is a little bit longer, but we wanted to have this discussion because the software 3.0 era needs a lot of builders, thinkers, and creators, and this audience is definitely fits that bill. So we wanted to kind of share, and we're going to bring a lot more of these ideas over the next few episodes here as well. All right, till next time. Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, And we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.